All right, in this podcast, we're going to have an introduction to the types of bonds that we're going to be talking about in AP Chemistry. All right, first off, let's talk about what is a bond. A bond is a strong electrostatic attractive force that holds atoms together. Why do things even bond? What's the whole point? Well, we're going to look at it in terms of energy later on in this chapter. And specifically, we're going to talk about bond energy, which is the energy required to break a bond. Why do we form compounds? Well, compounds are formed because it gives the system as a whole the lowest possible energy. All right, so let's start with our first type of bonding, ionic bonding. But first, let's talk about what an ion is. An ion is when you have basically a charged atom. So atoms are going to gain or lose electrons. They're going to do this in order to have a full octet, have that magic number 8, and that will make them more stable. So they want the same number of electrons as a noble gas, basically, because noble gases all have a full ring. They have 8 valence electrons. So an ion is when you have lost or gained these electrons, and it either makes you a positive or a negative. All right, as far as stability, we can see here that we have a pattern for how atoms make, atoms on the periodic table make ions. So our pattern goes 1 plus 2 plus 3 plus skip, 3 minus 2 minus 1 minus zip. Okay, so we're going to use this pattern, and it's going to show us that every element that is in like this first column, the 1 plus column, is going to have a 1 plus charge. And then everybody in the second column, the 2 plus, is going to have a 2 plus charge. And so on down the line. So you need to know that pattern in order to do ionic bonding correctly, make your life easier. In an ionic bond, you have 2 ions that are opposite charges. You have a positive ion and you have a negative ion. Positive ions are metals. Those are the ones that tend to lose electrons, and they're called cations. And then negative ions are called anions, and those are going to be your nonmetals. And so basically we're looking for 2 atoms, metal and nonmetal, that have a big difference in electronegativity. And then they're going to transfer the electrons. So you see down here in this picture, we have a transfer of electrons. So we have this electron, and it's transferred over to the chlorine. So the sodium loses one. Sodium's the metal. He becomes a positive ion because he has more protons than electrons. And then chlorine gains an electron, and he becomes negative because he has more electrons than he does protons. So you end up over here with this Na plus and this Cl minus. The attraction between that positive and negative charge is what actually gives the force of the bond. All right, how do you write an ionic formula? Well, you need to do a couple steps first. Step 1 is you're going to determine the oxidation number of the atom. What that really means is tell me the charge. After you do this, you're going to put the positive charge first, so metals always go first. Then you're going to swap and drop. You're going to swap your superscripts, that's the charges, and they become your subscripts. And then we're going to reduce the subscripts to the lowest whole number ratio. All right, so some examples. What's the formula for the compound formed between sulfur and aluminum? All right, well, we have sulfur. Let's make sure my pen's working here. All right, there we go. All right, so we got our sulfur. It's not really the best color. Let's find something a little friendlier, but red. All right, we got our sulfur, and it has a 2 minus charge because it is in the 2 minus column. And then we have aluminum. Aluminum has a 3 plus charge because it's in the 3 plus column. Now we need to put the positive one first. We're going to put aluminum first. We have 3 plus. Then we have our S2 minus. All right, now we're at the swap and drop. So we're going to drop this down, drop that down, and it becomes Al2, S3. Okay? All right, now look at the second one. The second one, we have aluminum again, so we know already that that is Al3 plus. And we have carbonate. Now be careful, this is not carbon. This is a polyatomic ion. CO3, 2 minus. Okay, so you have to be careful of those because they'll sneak up on you. That's our negative ion, and then we're going to swap and drop. So the 3 is going to come down, and the 2 is going to go over here. So we got Al2, and then CO3. All right, but we want this 3 to move down. We want to indicate that we want 3 of the whole entire carbonate ion. So we need to put it in parentheses and put a 3, just like that. All right, so far we've only talked about the trends, the 1 plus 2 plus 3 plus skip trends, and we haven't talked at all about these guys in the middle. So let's talk about what we need to do to find the charge of those. All right, well, these ones in the middle, they can do different things. So like iron. Iron can be 2 plus, or he can be 3 plus. He can lose different amounts of electrons, depending. Okay, so how do you know what his charge is? Well, there's one of two ways. Either it's going to be given in the name, in which case you have a Roman numeral that indicates the charge. So if you see a 2, that tells you you're dealing with a 2 plus iron. If you see a 3, that tells you you're dealing with a 3 plus iron. Or you have to back infer it from the formula. So here we have Sb and then Cl. Well, we know Cl has a 1 minus charge. Okay, so that's why we see nothing down here. Then this 4 had to have come from over here, right? So that means that Sb has a 4 plus charge. So sometimes you have to go backwards. All right, what's the formula for the compound form between sulfur and iron 2? Okay, so we have sulfur, which is a 2 minus, and we have iron, and it tells us that it is Roman numeral 2, so that means it's a 2 plus. Okay, so we're going to put the first one, or the metal first, the positive one first. That's iron 2 plus, S2 minus. Swap and drop, we get Fe2S, 2. And then we know that we need to reduce those to 1s because it is not in the lowest form. So our final formula is just going to be FeS. Okay? All right, how do you name an ionic compound? Well, the first thing you want to do is you want to write the name of the first element. Then you're going to write the name of the second element and change the ending to IDE. If you have a polyatomic in your compound, you just name it whatever the polyatomic is. And then if you have a multivalent element, that means somebody in the middle or the skip column, you're going to have to use a Roman numeral to represent the charges. We only go up to 4 for Roman numerals, so you got Roman numeral 1, Roman numeral 2, Roman numeral 3, and then 4 looks like a little IV. All right, some examples on these. Okay, so we have iron 2 and sulfur. Okay, so what is the name for this? Okay, well, we got iron, and we know that iron is in the middle, so we're going to have to use Roman numerals to indicate his charge. So we got iron 2, and then we got sulfur, and we're going to change the ending to IDE. So their name is iron 2 sulfide. All right, the next one, we have aluminum and carbonate. So aluminum, and aluminum's in the 3 plus column, which means we don't have to use a Roman numeral. And then carbonate is a polyatomic, so we're just going to use the name as it is, carbonate. Okay, just like that. All right, that's the end of the podcast.